I've had enough questions on this particular problem that I thought it probably was a good time to record a video on how to complete this problem. This is problem 3.7, number 10. And it's a problem where you're going to be finding the present value of an investment. And you're going to be using a formula from your book. So I have on the screen that on page 224 of your book, there is the formula for the continuous income stream. And we're going to be finding the present value of this continuous income stream. So let's read the problem. Find the present value of a continuous income stream, f of t equals 20 plus 6t, where t is in years and f is in thousands of dollars per year for 10 years. If money can earn 1.8% annual interest compounded continuously. So the formula from your book, the present value is the integral from 0 to t of f of t e to the minus rt dt. And they give us the continuous income stream function f of t. F of t is equal to 20 plus 6t. They also give us the interest rate R. The interest rate R is 1.8%, which we are going to write as a decimal 0.018. And then we're going to be looking at this investment for 10 years. So T is 10. So we are going to integrate from 0 to 10, f of t, which is 20 plus 6t times e to the minus 0.018 t dt. And I'm going to have to integrate this by parts. So the formula for integrating by parts, we're going to get u v minus the integral of v du. So I need to decide what I'm going to let u and v equal. So I'm going to let u be the 20 plus 6t. So if I take the derivative of that, I'm going to get du is 6, that's the derivative, dt. So I've got du now. Now I need to find v. So I'm going to let dv equal the e to the minus 0.018 t dt. And then I'm going to integrate both sides of that to find v. So let's integrate both sides. So v is going to be the integral of e to the minus 0.018 t dt. So that's going to be e to the minus 0.018 t divided by negative 0.018. Because when I take the derivative of that, I'm going to get e to the minus 0.018 t times negative 0.018. So I have to divide by it to get the integral. Okay, and I'm going to go ahead and do that. I'm going to go ahead and divide this out. So this is 1 over negative 0.018 times e to the minus 0.018 t. So I take my handy dandy calculator out, and this is going to be negative 55.5556 e to the minus 0.018 t. And I'm going to carry it out to 4 decimal places or so that I can mitigate the round off error I'm going to have. All right, so now that we've got our parts, let's find the present value. So the present value is uv, which is 20 plus 6t times V, which we found to be negative 55. And you have to be so careful with all the negatives in this calculation. If you lose one negative or you make one computational error, it messes everything up. So we're going to be really careful. Negative 55.5556 e to the minus 0.018 t, and we're going to be evaluating that first part at from 0 to 10. Okay, so that's that UV part we're evaluating at 0 to 10. And then we're going to subtract the integral from 0 to 10 of V, which we found to be negative 55.5556 e to the minus 0.018 t times du, and du is 6 times dt. So we're going to multiply that by 6 times dt. Okay, so we've got a minus. It's going to give us a plus, and we're going to multiply the 55.5556 times the 6. So we're going to get the present value is 20. For some reason, my notepad's trying to help me here. 20 plus 6t times negative 55.5556 e to the minus 0.018 t evaluated from 0 to 10. And you could go ahead and evaluate that first part so you don't have to keep writing it over and over and over again. Go ahead and put the 10 and the 0 in there and evaluate that. I'm going to wait till the end just because for some reason I'm waiting till the end. Okay, so what do we get? If we multiply 55.5556 times 6, I get 333.3333. And you notice it is plus because I have a minus. So times the integral from 0 to 10 of e to the minus 0.018 t dt. So now we can find that integral. So that integral is going to be 333.3333 times e to the minus 0.018 t divided by negative 0.018 t evaluated from 0 to 10. And we still have all that first part there. Plus 6t times negative 55.5556 e to the minus 0.018 t evaluated from 0 to 10. All right, so let's do our evaluation now. I'm probably going to go ahead and do the 333.3333, and I'm going to divide that by the negative 0.018. And I think I have a t in there, and that's a mistake. Sorry about that, folks. There shouldn't be a t there. There's no t necessary there. Okay, so if I take 333.3333 and divide it by negative 0.018, I get minus, what do I get? 18,518.5185 times e to the minus 0.018 t that we're evaluating from 0 to 10. And I still have all that first part up there. So we have PV equals 20 plus 6t times negative 55.5556 e to the minus 0.018 t evaluated from 0 to 10. All right, finally get to do some evaluation. So in the first part, I'm going to first plug in t equals 10. So when I put a 10 in right there, 6 times 10 is 60, plus 20 is 80. So we get the present value is 80 times negative 55 Sorry, I'm having notepad problems here. It's wanting to add stray characters. So if 80 times negative 55, and we just did a jump there, we just go with it. 55, 5, 6, e to the minus 0.018 times 10, because we're first evaluating that at t equals 10. So negative 0.018 times 10. So there's the first part of that. And now we're going to evaluate this at 0. So instead of 10, we're going to put 0 in for t. So we're going to get minus. Remember, when you're evaluating, you evaluate it at the top number, and then you subtract the evaluation at the second number. So we're going to subtract 20 times negative 55.5556, and e to the 0 is 1. Okay, so there is the evaluation of that first part. Now let's look at the evaluation of the second part. And my page is not long enough, so I'm going to write it underneath here. So if minus 18,500, and again, my notepad's trying to help me here. Try this again. Minus 18,518.5185. And we're evaluating e to the minus 0.018 first at 10, and then we're going to subtract the evaluation at 0, and that's going to be 1. So this is the calculation that I'm going to put into my calculator to calculate the present value. So 80 times negative 55.5556 times e to the minus 0.018 times 10 minus 20 times negative 55.5556 times 1 minus 18,518.5185 times e to the minus 0.018 times 10 minus 1. All right, is that good enough for you? Okay, let's go to the calculator. So let me share my other screen here that has my calculator on it. Okay. So here's my calculator, and I'm just going to type this big old long thing in. So I have 80. And you could certainly do this in intermediate steps. So you could do the evaluation, write that down on paper. Do the second evaluation, write it down on a sheet of paper. I just am too lazy. I do it all at once. So 80 times, I'm going to use some parentheses, negative 55.5556 times e, second natural log, e to the minus 0.018 times 10. I'm going to arrow out of that exponent, close those parentheses. Then I have minus 20. So subtract 20 times, let me get myself out of the way here. 20 times, what are we multiplying that times? Negative, use some parentheses, negative 55.5556, and it's times 1. I'm not going to times it times 1. We know that 1 is the multiplicative identity, and if I multiply anything by 1, I don't change that number. So we're just going to leave that off. I'm going to be lazy. And then we're going to subtract 18,518.5185. And again, I'm carrying those 4 decimal places just to try to mitigate the round off error in the end. The more decimal places I carry, the better my round off is going to be. Okay, and we're multiplying that times e, second natural log, negative 0.018 times 10. Get out of that exponent, and we're going to be subtracting 1. Okay, and I'm just going to do a quick glance at this and make sure that I have it typed in the same way that I have it on my paper. So I'm just going to go back over. Make sure I got all the negatives in there. I hope I do. Got all the negatives and the exponents on the e's. Looks pretty good. All right, so I'm gonna hit enter. And my answer is $449.35. So hopefully this will help you in doing this problem. If you still have questions, please feel free to reach out to me. Thank you. Bye-bye.